does nothing. Bump on a log. Or if you want to talk about somebody moving really slowly, you say you're moving slower than molasses in January. Because when you tap trees for molasses, like which makes syrup, if it's cold outside, it runs really, really slowly.
Now, how's that song about molasses from over the garden wall?
I have no idea what you're talking about. That is why I don't know what you're talking about. Alright, today, I'm thinking that this lesson should be fairly quick. We may even get to dabble into the next one just so we're ahead, and then like halfway through tomorrow we might just be done. But we're still working with similar figures. But now we're talking specifically about corresponding sides. So my sister and actually my good friend Justin went to school for graphic design. And one of the things they often deal with is sizing of stuff. And I know Savannah did a Discovery Day on graphic design. Yeah, if you don't do things in particular manner, stuff can very quickly look wrong. Like if you stretch one part of an image twice as big and the other part 3 times as big, that's not gonna look right. Unless that's what you're going for. Sometimes you're going for that kind of.
Yeah, sometimes. So when we did it, we had to draw it out and then take a picture and put it on the computer. But we wanted to make parts bigger or come out more.
Yeah.
So we had to use these little dots. And if you went out too much, then it would curve.
Yep.
And it would mess it up.
I know what you're talking about. I don't know how to do it.
It was on Adobe.
Yep.
Or something.
Probably Adobe Premiere, maybe.
No, it was Adobe. What's it called?
Creative Suite or something.
It's where you take pictures.
Does Adobe own Photoshop?
Adobe Photoshop.
I didn't know they own that now. So we are going to first today redo some things that we've done, dealing with scale factor. But then we're going to apply that to find out unknowns. So you and your team need to first, to make sure that we remember how to find scale factor, determine the scale factor in situations A and B up here. I am going to try very hard to just random card. Remember that you can pass, you can phone a friend, whatever. So don't get done and stick up a hand and expect me to call on you. I'm going to try very hard to random card. You usually only need a minute to do this. So find your scale factors of A and then B. They're 2 different scale factors. You shouldn't need one. Remember, to determine scale factor, we compare the new shape to the old shape, or the original. So here we could write SF equals, and then just show that comparison. Really, no one's sitting at a good table now?
Yeah.
I'm just gonna have to It's just more comfortable. Those chairs are just.
I've never said
If you didn't sit there, I would have sat there.
I mean, you still can. That statement kind of sounded mean. Do you realize how that sounded when it came out of your mouth? Braden, I would have sat there, but now that you're there.
I like to work alone,
Yeah, just bring a recliner in here. We can rotate who gets to sit in a recliner each day. Alright, jokes aside. Hey, class. I won't go random card on this because I think we can go class. What's the scale factor of A?
2. 1/2.
2. 1/2.
Yeah, I was going to say, I heard 2 very distinct different answers. We go from original to new, but the comparison we make is new to original. So we would compare the new to the original. It is 1/2.
Yeah.
We got smaller, guys. Right? The new. So if you said 2, it's okay. If we go the other direction, it's 2. But right now, we're going from the original to the new. Remember, you're thinking of what multiplier do we use? How do I multiply to make my new shapes? Now, B is a little bit tougher, so we will put somebody on the spot here. Okay, Octavia, fine. What are you thinking?
5 divided by 4 equals 1.25. 4 times 1.5 equals 1.
So you're saying from the original to the new, is it 4/5 or 5/4?
1.25.
Yeah, because we compare the 5 side to the 4 side, they correspond. And if we reduce that out, or not really reduce it, but simplify it to a decimal, it's 1 1/4, right? 1.25.
And so there was no changes.
Whoever's listening, I love music. And it could be carrying from somewhere else, or it could be birds in the ceiling, like I always think they are.
What?
So just if we're listening, please continue. All right, there was vent fans. You guys don't remember this? When I thought there were birds in the ceiling.
Yeah, I remember.
The vent fans were like making noise or something.
The word for
And-
at the gym once.
Yeah, interesting. All right, so obviously B was a bit more challenging than A. Right now, A, we had 2 different answers because you guys gave me both. Excuse me, that's perfectly fine. It is better for your brain to be able to think about both, like going both directions and those being reciprocals. But do be aware we got to go new compared to original in that division. So if we look here at 688, we've got a few different ideas from Claudia, Isaac, and Paula. And, you know, because they're in middle school, they want to argue and immediately tell their classmates that they're wrong. So what you need to figure out is what's your scale factor here and whose work is right. So with your partner, look through those. And all you need to write on your paper is SF equals and the work you're going to do to support what you tell me the scale factor is.
Well, it's one thing I'm already noticing.
It often does not come out to be a whole number. Often does not. What did you just say?
No, not English. English.
Sorry, I hold my dad. Simon, what do you think? Who's right? What'd you get?
I got a completely different number.
Well, you're holding a calculator, so I'm scared that you got a decimal number, and their numbers are all fractions.
That's a fraction.
Okay. Is it mixed? So put the calculator down. You don't need that right now. if we think about scale factor as being new compared to original, like in that division, new compared to original. That's what we're trying to analyze. We shouldn't really need to go here. Connor, what do you think?
Well, they're all the same.
What do you mean they're all the same?
Because I did them all. They all equal 3.5.
Oh, so you mean we have equivalent fractions here?
Yeah.
So this fraction's equal to that fraction's equal to that fraction.
Also makes sense because then how are you supposed to get a new shape if you don't use the equivalent? If you don't use the same scale factors for all sides.
So wait, are we saying that their middle school argument was moot and they're all right?
Yeah.
Every single one of them is right. They just chose different corresponding sides. So you said scale factor here is 3.5? Sorry, what? 7 over 2? Which, yeah, that reduces to 3.5. So if we wanted to give it as a decimal, 3.5, right? Now, you guys are pretty good at this, so time to step it up.
Come on, step it up.
So if we think back to the problem that had the scale factor of 5/4, but now we have pieces that don't exist. You and your team need to determine what's x and what's y. Realize they're on two different sheets. Why? Because I asked. Because you care to get better. You want to grow more.
But if I grow, I won't be able to be the small kid in the house.
That doesn't matter. You don't want to do something.
Yes, I do. Being small has its perks.
You could sketch it really quick on your paper if that helps. So the sides they had are how they got the scale factor, right? The corresponding sides where they had two of them. So sometimes when you look at these problems, you got to decide, what do I have that is actually useful to work with? But then when we go to determine x or y, Braden, you choose. Do you want to do x or do you want to do y?
For me, I did y first.
Do y first. So how'd you do y?
I did it so I divided 10 by 5/4, and I got 8.
I absolutely agree, but I'm going to do it different to get another option. So Braden said, instead of multiplying, going left to right, he divided going right to left. I agree. Totally right. But division by fraction kind of gives me the heebie-jeebies because it's tough. Maybe. So instead, we could multiply by what? The reciprocal. Because we said scale factors just turn around going the other direction. So if I take my 10 and multiply it by 4/5, I get 40 over 5, which is 8. See how that's just, I don't like division. I don't like any division, let's be honest, but I especially don't like division by fractions. So then, Gwendolyn, how'd you get your x? You look way too comfortable back there.
Me, I did 1.5 or 6 times 1.5.
1.5?
Yeah.
This isn't 1.5.
It's 1.25.
1.25, right? So if we do times 1.25, because that's our scale factor, what do we get for x? 7.5? That's probably why your brain was thinking 0.5. So guys, start to analyze, like wrong answers aren't a bad thing. Your brain does a wrong answer for a reason. Like you can normally trace down like, oh, my brain was thinking about that. Like I knew what I meant to say, but my brain was over here. Yeah, like over in like Collins' room. So, solve all these. Challenge.
Well,
Wait, which one's the original?
Doesn't matter. I'm not asking you for the scale factor.
Oh, right.
Ha cha cha.
Oh, wait.
Again, it's not gross. It's beautiful.
No.
Perfection in its finest.
I'm going to give you guys a good 5 minutes to do this. You have like 8 things to solve up there. I don't know, I think.
Yeah, we do. There's, yeah.
Careful to argue with a math teacher. That's always what I find. So if there was going to be anybody who might be interested in the offer I'm about to request, it would probably be somebody from this class. With that new Chromebook cart, we want to zip tie all the charger cords. So I'm going to run home on break. I also need to like go cash a check and buy new wiper blades. But on my break, because I'm going to take work home tonight, I'm going to go and get zip ties. So if later during AOR extensions, if you're mastered and you want to help us with that, I'm going to do a couple to like kind of show what needs to be done. But then just to come to us, me or Mrs. Goldring, and we'll have the stuff and we'll get you done. Thank you very much. I'm not surprised you're volunteering for this. I appreciate it. We're just trying to make life easier for everyone else, because as if you were on this side this morning, Mrs. Goldring was talking about all the people grabbing wrong chargers and cords everywhere. There's 30 in that cart. Yeah, there's Let's make sure we're all rolling okay. In A, if we look at a scale factor, what are our options of scale factor? In part A, what are the options of scale factor, George? 3 or a third, depending on which way we go. So I'm going to find y. I'm getting bigger. I'm going to use my 3, so y is
27.
If we're trying to determine our x, we're getting smaller, right? So we either divide by 3 or use the reciprocal and multiply. A third of 39, as somebody said already, is 13. So please continue on. I'm just going to write some work up here for what we did. Those are our 2 possible scale factors. We never divide with a scale factor. We're always saying that we multiply. So, like, yeah, you can divide going backwards, quote unquote, but that wouldn't be your scale factor. Our scale factor is either 3 if we're getting bigger, 1/3 if we're getting smaller. One more minute, I'll start calling on people. I like your face you're making.
Me?
Yeah, are you upset about a result or
No,
something?
it's not, definitely not right.
Well, go back and reanalyze. Wrong answer should be motivation. Oh, by the way, I have your test totally done and stuff. We're going to go over those on Friday.
Oh, it's wonderful.
About 30 seconds. Z, your choice. In B, give me X or Y. X equals 16. So if I look at scale factor getting bigger, my scale factor is 24/9. Yeah?
Yeah.
Okay. Kind of gross, right?
It
No,
was
wait.
like a really big number if you multiplied it on the calculator.
Yeah, Jessica. Yeah, how do I find Y?
Why is easy?
No, it's the same.
It's the same.
You guys are terrible. Jessica. Sorry, love you guys, but hold on, Jessica.
Oh, it's the same.
As what? As what and why? Ah, they're parallelograms. So this must be the same as the bottom. So get really used to this motion. Sometimes it just happens.
I kind of thought it was like weird.
That was good.
Parallelograms, right? Caitlin, if we go to C and we look to get X, Y, or Z, your pick. Y is 10, she says.
What do you mean Y is 10?
So, well, this is a convenient comparison. You have a 25 here that goes to a 10. We have a 25 here, it would have to go to a 10. Now, inconveniently, the other ones aren't as easy. Braylon. She did Y. We need X or Z. Okay. I don't know.
Well, so 8. So there's 8 here on the other side times 2.5.
Times 2. Ah, okay, so you're saying the scale factor when we go this way is going to be 2.5? So then 8 doubled is 16, and another half of it is Z. Yeah, Z 20.
Yep.
We agree. Guys, you'll start to realize, and I think Mr. Hall teaches a lot like this. Like, I am more and more not going to be the answer giver. We need to, as a class, decide if that's it or not. So if you have something else, speak up, or you need to be analyzing, like, did I make a mistake? Where in my work did I goof? And then X. Then I guess we could either divide by 2.5, but if I want to multiply, what would I be multiplying with?
5.2. Wait, no.
That doesn't make any sense.
0.25?
Oh, no.
This is 5 halves,
Oh.
right? And we could also compare 25 and 10. If we're getting bigger, that's our scale factor, 5 halves. So, if we're getting smaller, 2/5. And a 5 halves seems like an odd number. So if I multiply by 2/5, who's got X for me? Anybody?
Yes.
It's 7.
7?
7.
What do you think? D. Teak hooked me up with either X, Y, or Z. Because I asked. Sorry, I'm just trying to think. Okay, so Y. So you said Y, right? You got 48 over 6. How'd you get that? I'm real curious. Yeah. Right? If we compare little to big, little over big. And it doesn't matter which way we go here. We don't know which is the original and which is the new. So Teak, to find Y, needed to go from 6 to 4. So he uses 4 over 6. And then you took 12, so your work was probably this. Now, wait a minute. let's move some things around. Can I divide 12 by 6?
Yeah.
What do we get?
2
Times 4?
4.
Is this 8?
Yeah.
Let's not use a fraction if we don't have to.
Thank you.
So why is 8? Yeah? Verification? Yes? Okay. Mallory, what about X or Z?
Wait, that's a Z.
X is 9. So if we go this way, our scale factor flips over and it's 3 over 2. Or 6 over 4, but if we reduce. Octavia, what about Z? Can you take it home?
I never get complete points.
3.8. Can we get verification? Does this make sense?
Sure.
That is the question you should be asking yourself. Hey guys, hi. We're gonna either move on or be done here in a moment. I'm deciding, but you talking doesn't help. So when you do this, you should be asking yourself, does the value I just wrote down make sense for this problem? This shape needs to be smaller for every corresponding side. If you accidentally multiply by the wrong thing, you're going to get a bigger number. Go back and fix it. Quinn, please. Thank you. Are there any remaining questions on finding unknown sides when we're dealing with scale factor? You can go either way using your reciprocals. I think it'd be better to get ahead now, and we could actually start reviewing the mastery tomorrow, potentially. So not that you have to do this homework tonight, but let's go ahead and look at this next lesson real quick, because it's the last one in 6. And I'm betting with what we just did, we'll be able to do this. Encouragement, more than one way to solve. Right? There's more than one way to solve. So, Kenan, I think, loves trains. Now, the gauge of a train, anyone do train stuff in here? Because I don't really know much about this. I only know what I know from watching The Big Bang Theory. There's different gauges based off how it compares to the actual train. Obviously, you're not going to have a model train in your house with a scale factor of 1. That would be absurd. Or it would be your house. So, Kenan loves narrow gauge tracks. So, that's how wide the wheels are, right? So he decided to build a model train of the Rio Grande, sorry, is how you pronounce it. Popular narrow gauge train. Use the following information to let him know how big his model should be. So, I want to just stop and let you guys dive in and see if we can figure this out. More and more, we will start to throw you problems where you have to pay attention to units. So this is CPM being nice and giving you both, but as you move forward, be aware the problem will probably be more like the real one is 3 feet. The model one is 3/4 inches. And you have to identify, like, weight, feet, inches, I gotta make common units. So luckily, well, or nicely, whatever we want to say, they give us 36 inches for the rail track and 3/4 of an inch for the model track. If we go to set up my scale factor, what do I set up? Quinn?
3/4 divided by 36.
Now, again, division gross. But if I have a fraction on top, I'd rather have a fraction on bottom to keep things making sense. And then instead of stacked vertical division like this, what could we do? We write it out horizontally. 3/4 divide by 36 over 1. Okay, then we keep, change, flip, right? Can I cross-reduce here and make life easier? Can the 3 and the 36 both reduce by the same thing? Yeah, they can both divide by 3. So my numerator just becomes 1. My denominator becomes 48. So this, I don't know what gauge it's actually called, but what your ratio of describing the gauge would be 1/48 scale. So it would take 48 of your little model trains to be as long as the big one. It would take 48 of your little model trains stacked up to be as tall as the big one. And that is, I mean, trains are huge. Like, if you haven't ridden on a train, it's pretty interesting. So, shoot, we're not done.
But wait, there's more.
So the Rio Grande has wheels that measure 44 inches in diameter. Well, we know, we did circles already, yeah. So the wheel, the height is also the diameter. So think about that, guys. That's 44, so that's big. Bigger than 3 feet. That's over 3.5 feet. How big are the wheels on the model?
Itty bitty.
11/12. How'd you get it?
I got it by. No, you're not gonna like. Well, actually, no. I got 44 times. I got 44 times 138.
Once we know our scale factor, that's what we're multiplying with. Right? So this, I can put over 1, and this becomes 44, except my smartboard is way off, over 48, and they can both divide by 4. I know, my writing, it's not lining up with where I'm actually writing, so I'm sorry. Caitlin's very judgmental right now. If I divide by 4 to each of them, I get 11/12. So 11/12 of an inch. That wheel's less than an inch. So not quite as mammoth as your 44 inch wheels. I had a physics teacher in high school who loved trains, would travel by train a lot. His name was Mr. Stockdale, awesome guy. He would often, you know how you get teachers distracted. Like, if you ask me the right questions, we'll probably talk off topic for a few minutes. But anytime he could talk about trains, he would. And he would tell crazy, like, true stories of, like, you know how people put things on train tracks to, like, get them flattened or whatever? So, supposedly, this person was having that, like, thought, idea, whatever, and they put a rock on the train tracks, thinking, like, oh, this will be fun, like, it'll, like, destroy the rock or whatever. So they walk away from the train tracks to, like, be safe, and I don't know if we're going to do more math. And what this person didn't think about, you guys ever heard of Darwin Awards?
No.
Darwin Awards is kind of a really mean way of saying if you're not smart enough to survive, you don't get to survive.
Oh, no.
So if this is the train track and this is the rock dude puts on the train track, dude comes out here, sits down by a tree. Apparently this actually happened. Stockdale always told us real stories. What he didn't think about was the wheel of a train, and this is an interesting math situation, so that's why we're talking about it, but my smartboard is being stupid. This is the rail, right? So this is the rock sitting on the rail. The wheel of a train is actually shaped like that. because it has a lip on the inside to keep it in the track, and this probably just like goes straight up or whatever. But it's rounded to stay on the track but not be riding completely flat solid because the rails are actually slightly rounded.
Yeah.
What do you think happened when the train hit the rock?
It fell. You do that with the penny too.
No.
Like it's.
Yeah, the penny's flat. It will get crushed under the, like, so if I did this with a penny, my penny would be like sitting flat, right? It's just gonna probably get crushed.
No, so shot it out.
It did it hit the guy.
It shot out from the wheel and it hit the person. So it put it on the track.
Did it kill him?
I don't think it killed him. He ended up in the hospital. But just a little bit of like, think about what. So Mr. Dove, who used to work here, would always say, play what happens next. Like, think through. I put this thing under this thing that weighs tons, legitimate tons, and is going with a ton, that's not literal, but a lot of momentum. A little tiny rock stands no chance. But if it doesn't get destroyed, it's got to go somewhere. And dude got hit by his own poor choice.
I don't understand how you train
That's
them
why you
for
have to
anything.
find the.
If you Google it, you'll see what I'm talking about. Maybe we're just...
I wouldn't do stuff like
It
that.
doesn't make any sense to me.
I would do it, but then think what would happen.
Yeah.
let's see if I can find the right perspective. So you see kind of what I mean with the lip in the middle? I need like a head-on picture. That's a little bit better. So that's pretty flat, but they have like a mild rounding. And depending on how like the track is, the wheels can kind of flex and like lift and sometimes aren't always touching. So yeah, either that or Stockdale was seeing how much we would believe. But there have been plenty of stories of people getting injured by like poor choices dealing with trains.
Oh wait, I heard that. It's like a lawnmower and a rock.
Yeah.
Yeah, same idea there.
It's fun.
So we have like 3 more minutes, honestly. This class has felt long today. Let's just look at this really quick, and we'll pick class back up here tomorrow. So Heather and Cindy are playing Guess My Shape, and Heather has to describe a shape to Cindy accurately enough so that Cindy can draw without ever seeing it. Heather gives these clues. The shape is similar to a rectangle with a base of 7 and a height of 4. The shape is 5 times larger than the shape it's similar to. Do we have enough information to solve? If so, what are the dimensions of the new shape? Really how far we should go. We have 2 minutes. So think to yourself, do we have enough? 5 times larger, we know the base and the height. So what would my resulting shape be? We'll just go with anybody. Anybody else? Mallory? 35 by 20, she says. So our new shape would be a rectangle. 35 wide, 20 tall, and it's just scale factor of 5 being applied. So then when we look down here at part B, guess my shape clues to describe each of the mystery shapes below. Your clue should be complete enough for someone in another class to be able to read and draw the shape. And this is where we're going to cut for today. But if you were trying to make as minimal instructions as possible, because we want to make our life easy, we don't want to work harder than we have to, how could we minimally explain a similar shape and get somebody to accurately draw it using these as our originals? So that's where we'll pick up tomorrow. We'll probably maybe just do some quick work on similar figures and then review your tests. Have a wonderful day.